We are going to start by now talking about 3 dimensions. So up to this point, we've only worked with X and Y. Again, I'm going to wait until we have everybody back from being with the news crew outside before I actually show you what it looks like to have 3 dimensions. So we're going to get started with just the procedural aspect of it. I give you a system of equations like this, and I ask you to solve. How can we do that? Well, remember, one way we could do this would be to solve by substitution or elimination. And that's a really long process, and for that reason, we learn the RREF method. So in this case, I want you to ask yourself, how many unique variables do you see in this first problem? Anybody? Shout it out. How many unique variables? 3. There's an X and a Y and a Z. So for that reason, we are going to make boxes, and our boxes will be 3 down. This represents the number of unique variables. And in the past, I've had students say, but aren't there like 3 X's and 3 Y's and 3 Z's, so that's 9. No, it's the number of unique ones. So there's an X, a Y, and a Z. Now, when we go across the number of columns, I'm going to line it up. It's going to be X, Y, Z, an equal sign, and then this will be the constant. So I would like you to make, it's going to be a total of 12 boxes. And this is you showing your work. And each one of these boxes, what we're doing right now is we are setting up a matrix in order for us to use the RREF method to solve this. Inside of these boxes, I'm going to write the coefficients once I have things in order where it goes X, Y, Z, and constant. So hopefully after doing the lessons the last 2 days, this will make a little more sense. 3 is on the left side where it's supposed to, excuse me, I'm going to go back here. X is on the left side where it's supposed to be, so I get to put a 3 in this box. Y is on the left side where it's supposed to be. I get to put a 2. 5 is on the correct side. The constant's on the correct side. Nothing changes signs. Now, this is a really common mistake students make. When they look at the second equation, and we can cross this out so there's no confusion. When they look at the second equation, they're like, hey, isn't the X supposed to be in front, so doesn't it change sign because I have to move it? As long as the X is on the left-hand side, we don't need to do anything. So the X is on the left-hand side. The coefficient of the X is -2. The Y is on the left-hand side. The coefficient of the Y is 1. The Z is on the left-hand side. The coefficient of the Z is 6. And the 1 is on the correct side, the right side, coefficient is 1. Now, this third equation looks a little bit different. The third equation, X is on the correct side. I leave the coefficient as is. Y is on the correct side. Oops, excuse me, I put it in the wrong place. But the Z is not. The Z is not in the correct place. So when I move the Z over to the left-hand side, I have to subtract it. So when it actually lands on the left-hand side, it is not a 4, it's a -4Z. And the constant is on the correct side, the right-hand side. Can I have right now, even though you're probably still writing this down, can I have a thumbs up or a thumbs down if that made sense to you and you were with me in class? All right, grab your calculator. Please write down X equals, Y equals, and Z equals. And our goal in doing all of this is to find out, is there a unique X, Y, and Z that I can plug, bless you, that I can plug into each one of these equations and the left side will equal the right side. So always second plus 7, 1, 2. We're going to clear the calculator. And we're following the sign or the directions that are on the board, but we have some slight changes. Second matrix, go to edit. And this is where the slight change occurs. How many unique variables do we have this time? Because we've been doing 2, 3, but how many unique variables do we have? 3. And how many columns? Is always 1 more than the number of unique variables with systems equations, so it's 4. Please plug in the coefficients that we have put into each one of the boxes, pressing enter after each one. Now, after you've put them all into place, I'm going to follow along just like I see on the board. Second quit. Second matrix, I go to RREF, pressing enter, and now I place the matrix by going second matrix into that position, and I press enter twice. This is called, I actually pressed 3 times accidentally, didn't change anything. This is called the identity matrix. When you get the identity matrix on the left-hand side, our answers are on the right. And yesterday we spoke about, well, how do I know which answer goes with which variable? Just like we organize it X, Y, Z, from top to bottom, these will align with x, y, z. So x is 4, y is -3, and z is 2. When we return to school on Tuesday, we're going to see what does this look like if we actually graphed it. But because not everybody is here, we're going to wait on that part of the lesson until Tuesday. Let's go straight across, and let's look at this next one. The first thing I ask myself is how many unique variables do we see? Okay, I see an x, a y, and a z. Okay, so I'm going to do 3 boxes going down, and then I know there will be 4 going across. So I'm going to place in the coefficients, moving x to the opposite side makes it a -2x, a 1 and a 3 for the coefficients, and 8. Okay, x is already on the correct side, y is on the correct side. Oh, I got to move z over. It was positive, it becomes a negative. 9 is on the correct side. X is not on the correct side when it moves over. It's a positive 1x. Y is on the correct side, z is on the correct side, and the constant's on the correct side. Then take your calculator once you've checked, and I want you to actually crack the code using the RREF method. Remember, always do second plus 712 before you plug it in. It's really easy, especially if you have longer nails. It is really easy to mess up and plugging it in. So I always suggest going back and just making sure you've put in the correct numbers. Oh, I may have plugged something in wrong, or maybe we just have a really ugly answer, and that's okay. Let me check. I agree with the -2. Sorry, this is going to be a -2, a 1, and a 3. Oh, a -8. I see my mistake. The 8 had to move to the other side. A 3, a 3, a 4, a -2, and a 9, a 1, a 2, a 1, and 4. So I'm going to come back here, and I'm going to adjust this. Let's go into the matrix, and I can adjust this by making this into a -8. Now let's try this again. All the way down to RREF. Grabbing that matrix, and this looks a lot better. So my x is 5, my y is -1, and the z is +1. By a raise of hands, who is able to come up with the same answers that I did down below? All right, you ready? I'm going to have a timer going here, and I would like you to look at the bottom two without the help of anybody. I would like you, by the way, this is showing your work. Does everybody see this? This is showing your work to me. I'm going to give you, starting right now, I'm going to give you 3 minutes to do both the third and the fourth example before we dive into word problems. Ready? Begin. Raise your hand if you're done with the first problem. It's okay if you're not done with the first problem. Hands up if you're done with the first. Okay? I'm going to start working through the first problem while you finish the second. The x is on the correct side. It remains positive 2. The y is not on the correct side. When it joins the left-hand side, it has to change sign to become a negative 5. The z is on the correct side. Now, I don't want to make the same mistake I made in example 2. The constant needs to move to the right. It was a positive 6. When it moves over, it's negative 6. Second line, the x is on the correct side. The y is on the correct side. Oh, z needs to join the left. When it moves over, it becomes a negative 5z. And the same thing when the 30 joins the right side, it becomes a negative 30. It changes signs as it crosses over the equal sign. My last equation, x with a hidden hidden 1 is in front, is on the correct side. When 3y comes to the left side, remember it's x, y, z, and your constant. When the 3y joins the left-hand side, it becomes a negative 3. Z is on the correct side, and 21 is on the correct side. I'm always going to start by going second plus 7, 1, 2. Second plus 7, 1, 2. Here we go. So I'm going to go second matrix. I'm going to go to edit. There are 3 unique variables, so 3 by 4, always one more than the number of unique variables with systems of equations. And as I plug it in, I'm just going to slow it down to make sure I'm not making any mistakes in substituting in the numbers. All right, this looks good to me. And now I'm going to go second quit, second matrix, go over to math, going all the way down to RREF, grabbing that matrix, and this is what I have. Well, what does this mean? Well, I have the identity matrix on the left. Identity matrix has only zeros and ones, with ones going down the diagonal. On the left-hand side, from top to bottom, is my answers, and it's organized just like I have it, x, y, z. So x is negative 3, y is 2, and z is 5. Can I have a 1 through 5 if you're in front of me and how well you understand this? Okay. I'm going to do this one a little bit quicker. If you could do me a favor, and just watch. Unless you're not done, then continue. 1, negative 6, negative 2, and negative 8. Nothing needs to be moved. The x is in the correct place. The y is in the correct place. When the z jumps over to the left-hand side, it changes signs. 18 is in the correct place. If you see me make a mistake, let me know. X joins the left-hand side, it becomes a negative 1x. Y and z are where they're supposed to be, and the constant. So I'm going to go second matrix, and I'm editing 3 unique variables. And here we go. 1, negative 6, negative 2, and negative 8. 3, negative 2, negative 4, and 18. Negative 1, 3, 5, 3, and 2. Second quit, second matrix, go down to math. And we're going to plug that in. This is what I have. So I have x is 4, y is 3, and z is negative 3. Okay, one last time right now, if you had to take a quiz, which is not coming up, whether you're watching this video or you're here live with me, if you had to take a quiz on something like this right now, thumbs up is I could do this right now, I'd be ready. Thumbs to the side is I feel like I need a little more practice. Thumbs down is I'm feeling a little bit lost with this. Where are you right now? So you flipped right now in your packets, and now we're going to take this and apply it. This is the whole purpose of things. The whole purpose of things is that we are going to solve a system of equations. This time we have 3 different variables, and when we solve it, really we're finding that intersection point. If we think of it graphically, we're going to talk more about that when we return to class on Tuesday. Tomorrow you're doing an ACT activity. But here's what we're going to do. We're going to identify the 3 variables. Based on the word problems. We're going to solve it, and then we're going to answer the questions. But the first thing, if this is going to work, is that you understand some basics. Okay, I need 2 individuals to raise their hand and give me a name. 2 individuals. Not all at once. Thank you, Luis. So L is for Luis. Okay, L is for Luis. D is for Danny. Okay, who wants to do better on the next test? Oh, Luis, Danny, you didn't raise your hand fast enough. Okay, are you ready? Is everybody listening to this? We need to write an equation, and the equation can only include an L for Luis and a D for Danny, and it relates to the Unit 1 test. If I tell you that Luis scores 1 more than double Danny's score, 1 more than double Danny's score, and we have to write an equation So there's going to be an expression on the left and an expression on the right, and they have to equal each other. You can use numerical values, but you have to use an L and a D. I just told you that Louise scored one more than double what Danny did. Okay, you ready? I'd like you right now to flip to the very back of your packet where I believe there is a blank. Am I correct? Is blank in the back? And right now, working in teams, I'm going to give you 30 seconds to see what you can do. 30 seconds, what can you do? Come up with what you believe looks like an equation that is true. 30 seconds, begin. So I should hear you talking, whether you are watching this back or you are live. 30 seconds. Louise scored one more than double of Danny's score. So when we do this, I often think it's easier if we come up with some actual value. So let's do this, you ready? If I made this up, arbitrary, let's make this up, and I'm like, hey, Danny, I'm sorry, but you got a 40% on the first test. We're making that up. What would that make Louisa's score? Anybody? That would make Louisa's score 81, because I doubled it and I added one more to it. So I just came up with some arbitrary numbers that are going to work. And now I'm going to test it. So look what you have put down on your paper, and you're going to test it. And I'll tell you in just a little bit what I often see students do. Go ahead. These are common equations that I see. Common equations that I see, something like this. Now, there could be variations of this. But how can I tell which one is correct? Well, one way is taking these arbitrary values that make sense based on the description I gave you and plugging them in. So let's try this. If I plug in 40, 2 times 40 is 80. 80 plus 1 is 81. I like this equation, or a variation of it. Let's try the bottom one. If I take 2 times 81, okay, that's 162. And I add it, I'm at 163. Does 163 equal 40? No, it doesn't. So I like this or a variation. If you're like, Miss Bradley, like, what do you mean a variation? So I'm going to just erase this. 2D plus 1 equals L. 2D plus 1 equals L. Let me write that down. 2D plus 1 equals L. Okay, this is the equation, but a variation could be like 2D equals L minus 1. That'd be a variation of it. They both are correct. If I plug in 81 for Louise and then plug in for Danny 40 into either one of these equations, it will be true. Okay, let's try the next one. Okay, within your teams, make sure you are talking. You will not go home with homework as an individual group, whether you're watching this, if you're with me live, or you're watching on video if I see you talking. Here's the problem. I did not proofread this, so if we see some mistakes, my apologies. I want you to come up with an equation after reading it in less than 1 minute. Ready, get set, and begin. So we have two individuals. We have Sarah and we have Brianna. And I'm going to let S equal the number of points that Sarah scored in last night's basketball game, and B is going to be the number of points that Brianna scored. Now it says Sarah scored 13 more points than Brianna. Well, let's just make it really simple. Sarah scored 13 more. So let's just make it easy. I'm going to come up with an arbitrary value. If Brianna scored 10 points, how much did Sarah score? 23, because you added an additional 13 points. So I want you to come up with an equation. Don't use the 10 and the 23. You're going to use a B and an S and any other values. And I want you to come up with an expression that when you plug in 10 for Brianna and you plug in 23 for Sarah, the equation makes sense. The left side equals the right side. Does anybody have a guess what this could look like? One option. Okay, let's go. What do you think? Let's try. B plus 13 equals S. So if I plug in 10, I get 23. 23 equals 23. That works. Now, is there another variation of this that could work? There is another variation that's, oops, so sorry. There is another variation that's still true. Another variation would be what, Louise?
S minus 13 equals B.
So if I take 13 away from, Sarah's score of 23, these are arbitrary numbers that fit based on the information I was given. 23 minus 13 is 10, so that's true. This is great. Okay, let's try another one right now. We're going to speed it up. You're going to read this, and I want in 20 seconds, I want you to come up with an equation that works. This is all leading up to what we're doing later today. How many of you are like, Miss Bradley, once you put down arbitrary numbers, like, then I understand like how it works, but I'm confused how to choose the arbitrary numbers. Hands raised if that's you. Thank you for your honesty. So let's look at this. Danny has 3 times as many quarters as pennies. So let's just choose pennies. Let's choose like any number. Let's just say 7. We got 7 pennies. Got it? I just chose an arbitrary number. Danny has 3 times as many quarters as pennies. So 3 times 7 is 21. So I chose an arbitrary number. I went back into the reading to make sure it makes sense. Yes, okay, there's 3 times as many quarters as pennies in the arbitrary numbers I made. And now I need to come up with a statement. Within your groups, let's go 15 additional seconds. Make sure you're talking right now. What do you think you could come up with? Wrong answers are fine. We can adjust those, but you got to make some effort. Ready, get set, go. How do I make these 2 numbers equals what I'm asking you? How do I make 7 equal to 21? You can multiply it by numbers. What do? 3 times P equals Q. Let's check if this works. Is 3 times 7 equal to 21? Now, there may be others out there that were like, but I didn't use those numbers that you chose. I didn't use 7 and 21. Okay, awesome. You used 4. Let's pretend you used 4. So if you used 4, how many quarters would there be? Come back here. How many quarters would there be if you chose 4 pennies? There'd be 12. Let's see if this works. Is 4 times 3 12? It works. This statement works. Now there could be variations of that. You could divide by and have Q over 3, and that would work as well. It's probably a little more complicated. Okay, let's try to do this one, please. Without my help, let's give you a little more time. Danny wants to come up to the board and do it. I love it, Danny. This is good, right? Okay. We got 2 people. We have Aaron and we have Jose. Aaron scored 10 less than twice the number that Jose scored. So this is really very, very similar to the question with Danny and Luis. I'm going to walk around. If you are watching this but not live, please make sure that you are attempting to come up with an equation. Bless you. Bless you. I believe the thing that really stumps kids is like, well, how do I come up with numbers? So who scored a lower amount? Was it Jose or Aaron? Aaron scored 10 less than twice the score of Jose. Aaron scored 10 less than twice. So which one has a smaller amount, Aaron or Jose? Aaron does. So let's come up with just a low number. Let's say it's on a normal test, you can get up to 100%. Let's come up with a low number. Like, I don't know. Let's go with like 30% this time. So Aaron scores a 30%. All right, now what does Jose score? Aaron scores 10 less than twice the score of Jose. So 10 less than that. Well, if I bumped up 10, I'd be up to 40. And then what's twice 40? Twice 40 is 80. Let's see if this makes sense. Is 30 10 less than twice? Is 30 10 less than twice? Talk in your groups. Do you agree or disagree? Aaron scored 10 less than twice the score of Jose. So I think it's easiest first to go, well, what's twice Jose, right? Well, twice Jose, if Jose was 40, 40 doubled would be 80. Okay, yeah, this is twice. Jose is twice Aaron, but it's 10 less than that. And that's why I put myself here for Aaron, put Aaron at a 30. So these are some arbitrary scores. I would like you now to go and write an equation. What could that look like? Talking in groups, ready, go. Talking in groups. I'm going to give you two different ones because I believe that there's a lot of students, this is difficult, that may have this wrong. And there can be different variations. Do you believe in either one of these variations? Do you believe, yes, I believe that's the correct one? Hands up high if you believe one of those represents the correct answer. Don't raise your hand if you don't. Okay? And if you believe it, talk in your groups. Why do you believe? What is your evidence that makes you believe one of these is correct? Does it work or does it not work? Or do we need to change something is what I'm asking you. So let's check. This is why using arbitrary numbers works. 2 times 30 is 60. 2 times 30 is 60. Did everybody hear that? 2 times 30 is 60. Then when I add 10 to 60, do I end up with 80? That doesn't work. So maybe I need to do something different here. 2 times 80 is a really large number. What if I did this? What if I did half? What if I did half? Because we know that Jose is less than half of Aaron. So if I rewrite this bottom one to say half of Jose minus 10 equals Aaron, I want you to look at this bottom one. What is half of Jose's number if we use this arbitrary number? What's half of 80? 40. And then if you subtract 10, do you end up with Aaron's number? This is our equation. So you do need to play with it. You need to go back and ask yourself, what is the connection? Well, Jose is half, but it's even more than that. It's 10 less than half. This is our equation. Now, what are we doing with that? Okay, so if you've ever been to, I think it's changed names, but on 83rd Avenue near McDowell, there is a concert facility. Do you guys know what I'm talking about? Yeah. If you've ever been there, it's kind of fun. You can sit on the lawn, or I mean, you could pay more money and sit down below, but it's kind of a nice place to go listen to concerts. So I would like you to look into your packet. Do you see this in your packet? Yes, no? All right. So I'm going to switch over right now as I'm filming this, and I'm going to switch over and so that we can see this, and this is the equation. All right, here we go. Seats in the front section of the amphitheater stage cost $30. So I'm a visual person, so I'm going to draw a little picture here. Here's the amphitheater. So seats in this region, this is going to be the front region, cost $30. Seats in the middle section cost $25. And seats in, do they talk about in the lawn section at the very back, seats in the lawn section, does it say how much, I maybe got my numbers wrong, are $20. There are twice as many seats in the middle section as the front section. When all 19,200 seats are sold out, the amphitheater makes $456,000 when the ticket prices are this exact amount. Determine how many seats are there in each section of the amphitheater. Well, just like yesterday, we had to come up with what are the different concepts here. So one is cost. Let's come up with this. One is cost per seat. One is cost. One is total number of seats. And then I'm going to underline, there's one statement that's comparing the two. I'd like you to also underline this. The order in which we do these does not matter. I'm going to start with the cost. Now, I'm going to let, in this problem, I'm going to let F represent the total number of seats in the front section. M is going to be the total number of seats in the middle section, and L is going to be the total number of seats in the last section. All right, that's not a good acronym. I should change that. Okay, here we go. So let's start with this. F, how much does it cost for a front section? If I do the cost, how much does it cost for the front section? It is $30. For the middle section is 25. For the last is 20. And in all, the amphitheater takes in $456,000 in ticket sales when all seats are sold out. So I've created an equation that talks about cost. Now I'm going to create an equation that talks about the number of seats. Run the front, the middle, and the lawn seats are filled up. There is a total of 19,200 seats. I'm going to press pause, and I would like you in groups to see if you can come up with an equation that involves only middle and front, and then we're going to talk about it. I'm going to give you 1 minute. So come up with your equation, and I think you should choose some arbitrary numbers to ensure that you. So what I'm hearing groups say is I'm hearing things like this. Okay, we know that we're only talking about the front and we're talking about the middle. And before I actually write down the equations that I'm hearing groups talk about, let's come back here and let's reread this. There are twice as many seats in the middle. So the middle has twice as many as the front. So I'm just going to choose some random arbitrary numbers. The middle has twice as many. So if the middle has a 100, what would the front have? 50. The middle has twice as many as the front. I just throw some random arbitrary numbers, making sure that this coincides with what is said. Now, here's what I'm hearing groups say. I'm hearing 2m equals f, and I'm also hearing 2f equals m. How do I know which one would be right? And there could be different variations of this that will also be true, but how do I know which one would be right based on using arbitrary numbers? Well, let's plug them in. When I take 2 times 100, do I end up with 50? No. When I take 2 times 50, I end up with 100. So I'm going to come over here and I'm going to write 2f equals m. Make sure you're keeping up on your paper right now. How many unique variables do I have here? 3. There's F, an M, and an L, so make 3 boxes going down. Now we're going to come up with a system of equations, so we're going to have 4 going straight across. And it's really nice because my first equations really lined up pretty. So 30 is the coefficient, 25, 20, and 456,000. When we plug this in, we do not put in the comma. Now in front of the F, the M, and the L is a hidden 1. So 1, 1, 1, and 19,200. The last one is tricky. When I organize this, I'm going to slow this down for us. When I organize this, is F on the correct side? It sure is, so there's a 2. Let's go with the M. The M should be next. M is not on the correct side. When it joins the left side, the positive 1M becomes a negative 1M. Does this equation have any L's? It does not. We put a 0 in. On the right-hand side, the M has moved to the left. Is there anything left on the right-hand side? There is not, so we put a 0. Grab your calculator. Second plus 712. And we're going second matrix. We're adding it. There's 3 unique variables. And plugging in 30, 25, 20. Once I have plugged this in, I'm going to go second quit, then second matrix, going to RREF, substituting the matrix. What does this mean? How do I know within your groups, how do I know which value, because we do have the identity matrix, so these are correct, which value represents the front or the lawn, the number of lawn seats, or the middle? Talk in your groups right now. Go. Talk in your groups. Because we organized it with front first, then middle, and then last, that's how I know what's on the side. So there's a total of 3,600 front seats on this at this amphitheater. There's a total of 7,200 middle seats at this amphitheater. There's a total of 8,400 lawn seats at this amphitheater. We're going to look down below, but first we're going to read this one together, so give me 1 second to go on to the next one. Here is your, here's your next one. You're going to see it down below on the bottom half of the page you are currently looking at. I'll read it out loud. Diana goes to an amusement park to ride the roller coasters, the bumper cars, and the water rides. By the way, who here, whether you're watching this live or you're watching this by raise of hands, who here enjoys the thrill of being on a roller coaster if you've ever had that opportunity? Okay. The wait for a roller coaster is 1 hour. The wait for bumper cars is 20 minutes longer. And the wait for a water rides is 5 minutes long. I want to reread that. The wait for a roller coaster is 1 hour. The wait for bumper cars is 20 minutes. And the wait for water rides is 15 minutes. Dinah rode 10 total rides during her visit to the amusement park. Because she enjoys roller coasters the most, the number of times she rode the roller coaster was the sum of the times she rode the two other rides combined. If Diana waited in line for a total of 6 hours and 20 minutes, how many of each ride did she go on? What I'd like you to do right now is I want to give you an ample amount of time. Please come back. Within your groups right now, you have a little less than 10 minutes. I want you to go through this. I'm going to give you one helpful hint. Just like I underlined up above, I want to help you here. Let's go through this. I want you to underline this. So we have an equation that's going to talk about the time she waits in line. We have an equation that talks about the number of rides that she goes on while she's there. And then we have an equation that represents this. Please do that. After you write your equations, remember you're probably going to have to do something similar like this to get to the last equation. Come up with your boxes and then solve before writing a complete sentence to answer. Okay, under 10 minutes, begin.